So now we're going to take parallel lines and relate them to triangles. We're going to spend an entire chapter on triangles, but right now we're going to introduce a couple topics to be able to relate them to various angle pairs with parallel lines. So the parallel postulate said that through any point that's not on a line, there's one parallel line. So if I have this line here, line L, and I pick any point, point P, there's only one possible parallel line to line L. And then an additional one, sum of the angles in a triangle is 180. Triangle angle sum theorem. What we're going to do with this is look at line AC, and we're going to draw a parallel line through line B, or through point B, sorry. So when I do that, now I have two parallel lines, and I'm going to be able to use my parallel angle properties to help with things inside of a triangle. So triangle exterior angle theorem says that the measure of each exterior angle of a triangle equals the sum of the measures of the two remote interior angles. So the remote interior angles are the two that it's not touching. So if I take any line of a triangle and I extend it, so I'm extending that so it's a ray, that forms an exterior angle. That angle is the other two added together. We're going to use that property a lot in this section. So let's start by looking at a couple problems, finding x. For the first one, I know that three angles of a triangle add up to 180, so 62 plus 46 plus x equals 180. That doesn't look like an x. There we go. All right, so what I'm going to do is I'm going to subtract 62 and 46 from 180. Actually, let's combine like terms first. When I combine like terms, I get 108 plus x equals 180. So x is 72. Now over here, I know this is a right angle, which means it's 90 degrees. So 50 plus 90 plus my third angle, x plus 46, equals 180 because there's 180 degrees in a triangle. So I'm going to combine like terms. I'm going to take the 50, the 90, and the 46 and add them all together. I get 186. 186 plus x equals 180. When you subtract 186, you get x is negative 6. Now you might start to think, wait a minute, you can't have a negative number. If I plug that back in right here, if I plug negative 6 in, I get that the angle is actually 40 degrees. And that is possible. I can have a 40 degree angle. It's okay to have x negative. You can't have an angle measure be negative. Let's look at our next example. We want to find x, y, and z. So what I want to do first is I want to look at, and I'll trace it in green, I want to look at this triangle first. When I look at that triangle, I know that the three angles in the triangle will add up to 180. 28 plus 39 plus x equals 180. So I'm going to combine like terms. I'm going to add the 28 and the 39. 67 plus x equals 180. So then take 180 and subtract the 67, and you get 113. Now that x is 113, that's not right. Okay, 113. Now that we have that's 113, I want to find y. Now if I hide everything else in the picture and I was able to only focus on just x and y, they're a linear pair. So x plus y equals 180, but I know x is 113. So when I subtract 113, I get that y is 67 degrees. Now that I know those two, I'm going to go ahead and find z. And what I'm going to do is I'm going to use the exterior angle theorem that we just looked at earlier. So I'm going to erase this green writing on here. Let's just erase everything. I'm going to trace this in a different color. So we have this triangle right here. And what I'm going to do is I'm going to extend this line out this way. Now that I know this is 113, I know that that's equal to 64 plus z, because those are the remote interior angles. So if I take 113 and I subtract 54, I get that z is 49. Here's another exterior angle theorem. Let's move this down so we can actually read the words. Exterior angle is equal to the other two added together. So let's call that x. So x is 62 plus 51. So x is 113. Over here, other way, let's call this one x. We have 106. The exterior angle equals the other two added together. So I'm going to take 106 and subtract 64 and get 42. And then our last example here, let's add some variables in. I know the exterior angle is equal to the two remote interior angles added together. So when I add those two together, I get this expression. I'm going to combine like terms. I'm going to take 110 and subtract 26. So I get 7x equals 84. And then we divide by 7 to get x is 12.